So at the end of last video, we give you an overview of energy flow and chemical cycling. Here it is the a diagram that gives you the overall view of these two. The red arrow is the energy flow. The gray arrow is the, you may call it chemical cycling. So all energy comes from the sun, and the producer absorb the solar energy, and then it will produce food or glucose through photosynthesis. But during the process, some of the energy that the producer absorbs from the sun solar energy will become heat lost to the environment. And then when consumer eat the producer, they will also lose some energy as heat. And then when consumer die and the decomposer feed on the consumer, some of the energy also lost as heat. And then they will, then the decomposer will be able to break down the consumer into inorganic nutrients so that it can recycle back to be used by the producer. So the gray arrow, the nutrient on the chemical cycling, is that after the producer absorbs this inorganic nutrient in the nutrient pool of the environment, then it can produce food for the animals, so that after the consumer eat the producer, they will take the inorganic nutrient directly from the producer to support their body, to build their own polymer, basically. And then after they adapt, then the decomposer break down the polymer in the body of the animals, and then so that it will break down into not just monomer, but even simpler inorganic molecules for the producer to use. Energy balance. Well, according to the first law of thermodynamics, energy will always lost to the environment through, let's say, for the animal or for the producer. Both animal and producer will do cellular respiration, and cellular respiration can produce heat to lose to the environment. And then during the growth and reproduction, it will provide energy for the carnivore to feed on the herbivore and the plant. The death, excretion or defecation of the animal or plant, they will provide energy to the detritus to feed on. So energy flow can be represented by food webs, but food webs is composed of food chain, individual food chain. So we start with producer like trees, and then caterpillar feed on the leaves of the trees, and then mice and rabbit, they feed on the leaves or the caterpillar. The birds and other larger animals, they feed on fruit or nuts of the tree, and they also eat on the caterpillars. And then a herbivore, an omnivore, they provide food for the carnivore. So all these are the example of the food. All these are the example of the food web. Now the detrital food webs. The detrital food webs begin with the detritus, which is the food for the detritophores. These are the detritophores. The detritophores, they can be fed on by the salamanders, shrews, or above ground, or the carnivores. So these detritophores will be fed on by the carnivores. And therefore, this detrital food webs and grazing food web, they are connected. Because the detrital food web become the food for the carnivore. So that's how they connected by the carnivore. So this is the example. The bottom panel is the B part. The panel B is the digital food web. Panel A is the grazing food web, and they are connected by the herbivore or omnivore. So, as I mentioned before, the food web is composed by food chain. So, we call the food chain is composed of different trophic level. So, for example, these leaves is one trophic level, caterpillar is the second trophic level, tree birds is the third trophic level, hog is the fourth trophic level. And for this, we call it a one food chain. And this is the grazing food chain. And then the detrital food chain consists of the detritus, the partially decomposed organic matter serve as the food for the detritivore, earthworm. So this is the first trophic level. This is the second trophic level. And then the shrews, they are the carnivore on the ground. They are the third trophic level, and this connects to the grazing food chain. So we have the trophic level. We can call the trophic level as the primary producer, which is the leaf or the detritus. Primary consumer, caterpillar, earthworm. Secondary consumer, tree birds and shrews. So with the food chain and the loss of energy, the food chain is, we have the food chain because the higher trophic level consumer, they have less energy. Each trophic level, they will lose some energy. Remember the first law of thermodynamics? Each trophic level will lose some energy. So it said that about 10% of the energy of one trophic level is available to the next trophic level. That explains why we have fewer and fewer carnivore in the higher trophic level. And we can depict this situation, the energy flow, in a pyramid. And this also explains why carnivore, we usually need to eat a lot of food. We need to eat lots of food to compensate the loss of the energy. So you see that at the producer level, we have the most energy here. And then herbivore, we have less energy. Carnivore, we have less energy. And then the top, people are always saying, someone or the shark or someone is on top of the food chain. So when you are on top of the food chain, you actually get the least amount of energy. And that's one of the reasons people become vegetarian, because they know that when they eat the producer only, they can consume the most energy. That's one of the reasons vegetarian, they propose that eating producer is the good way to acquire energy. Because if you eat the top carnivore or other carnivore, you acquire relatively less energy. That's why you need to eat a lot of meat in order to feel fullness. But you don't need to eat that much of the producer, and then you can feel full already. Biomass. other than energy, we can use the mass of that living organism as a way to construct the pyramid. By the weight or by the mass, we use the mass instead of the number because mass is more accurate in the sense that this is an example, and one oak tree can have 100 caterpillar, but which one has a heavier weight or larger mass? Of course, one oak tree has a larger mass than 100 caterpillars. So the biomass of autotroph is much greater than that of the herbivores, because we need to have enough of the producer autotroph in order to support the herbivore. That's why the biomass of autotroph is a lot higher than the herbivores. And the biomass of herbivore is also greater than that of the carnivore because we need to have enough herbivore to support the carnivore. So the biomass pyramid is similar to the energy pyramid, but there is an inverted pyramid in the aquatic ecosystem. So in the aquatic ecosystem, it is the opposite. The herbivore, the biomass of the herbivore is a lot larger than the biomass of algae. The algae will reproduce really quickly to feed the herbivores. Now we finished talking about the energy flow, and we'll start to talk about the chemical cycles. Biochemical cycles, we have a biotic and geological component. In the next few cycles that we talk about, for example, carbon cycle, nitrogen cycle, all the cycles that we talk about, they consist of these three components. Reservoir, they contains all the inorganic nutrient or inorganic matter. But producers cannot utilize those inorganic resources in the reservoir. Then there's an exchange pool. Exchange pool is that the inorganic nutrient in the reservoir, they will go into the exchange pool so that the organism or the producer or the consumer, they can acquire the inorganic nutrient from the exchange pool. An example of exchange pool will be atmosphere or soil, or the example of reservoir will be rocks, fossils, or deep sea sediments. Biotic community will be the food web or food chain. Food web or food chain, so that the chemical will be recycled among themselves. It says that they may not even recycle, they may not go back to the exchange pool. They may or may not actually. They may or may never go back to the exchange pool. So take a look at the picture, it will be easier for us to understand. The reservoir may be the fossil, the rock, or the sediment deep in the ocean. And then the exchange pool can be atmosphere, soil, or water. In this case, it is the water here. So the inorganic nutrient may dissolve into water so that the community here, they can, especially the producer, can absorb the nutrient from the exchange pool, the water. Then the producer will provide food for the consumer and decomposer, so on and so forth. So that's why you have these three different pool, and then human activity can actually directly convert the inorganic matter from the reservoir to be utilized by the community. Because, well, we are human beings, we can do anything we want. And then, in all these biochemical process, in all this biochemical cycle, we have gaseous cycle and sedimentary cycle. Gaseous cycle, as the name suggested, they involve in the atmosphere. Example is carbon or nitrogen cycles. Sedimentary cycle, they involve the ground, the soil, the ground only. Example is the phosphorus cycle. And then we have water cycle. Water is an exception because it has both the gaseous, liquid, and solid state. So it go to all, it spans to all these two cycles. As a matter of fact, carbon cycle and nitrogen cycle, they also go to the, not just in the gas, not just in the atmosphere, they also go to the sedimentary cycle. Because carbon, it can form a solid. Nitrogen, you can also form solid. We'll see them in the next video.